This is our third video in a series of 4 about building a portable solar camping supply, and also called a solar generator. And in this one, last time we talked about matching the battery to our needs. This time we're going to talk about matching the solar panel and controller to our needs. Let's start out with the solar panel. The last video we said that we're going to need a 12 amp hour battery. You can go back and look and see how we came up with that, but we added up all of the devices we thought we were going to need, and that's where we came up with our estimate of 12 amp hours. Our next step is solar panel matching. So I have a rule of thumb, and it says I need enough solar panel to charge my battery in around 3 hours of strong sunlight. So on a typical day, you can get the equivalent of 3 hours of strong sunlight. Even if it's cloudy, whatever, you can get about that much. And I've found that that's about 95% true. So that will compensate for less than perfect conditions, cloudy days, or a leaf falls on your solar panel, something like that. So 12 amp hours divided by 3 hours is going to equal 4 amps of solar panel input. And 4 amps of solar input for 3 hours will give me a full charge on a 12 amp hour battery. 3 times 4 is 12. 4 amps at 12 volts is 48 watts. We can call it 50 watts for a panel. So our panels are roughly 12 volts, and this is going to build in some spare power. So if we use a 50 watt panel, that will meet our needs. For a battery, we have to use some common sense when you're doing the math here. You cannot use like a 500 watt panel and charge the battery 10 times faster. It would just blow the battery up, okay? So the numbers are not scalable. You can't just say, I'm going to get a huge solar panel, hook it up, and I'll charge it in 3 seconds. It doesn't work like that. Batteries have a minimum charge time. So a lot of batteries will require, at least a minimum of 1 hour to charge. So they have a maximum charge rate, and with a gel cell, it's roughly half the amp hour rating. So in many controllers, they're not smart enough to limit the input. So you can overcharge a battery. If we used a gel cell in our example, we'd be limited to 6 amps, or 6 amps times 12 volts, or a 72 watt panel. So our maximum that we could use in our example is a 72 watt panel. You could, otherwise it's not going to do you any good. If you can either overcharge the battery and kill it, or if you've got a good solar controller, it will cut it off and it won't allow it to charge too fast. I said overcharge before, but I mean overcharge in the sense of too fast. Also, when you're buying solar panels, amperage is better than voltage. A whole cell panel, now some of these panels are made up of partial cells, solar cells. A whole cell panel is best for this reason. So for example, a 50 watt panel at 22 volts gives 2.28 amps. A 50 watt whole cell panel at 17 volts, and that seems like it's got less volts, will give you 2.94 amps. That's half an amp more, and it's amperage that charges the battery, not the voltage. So you want the amperage. Our power output requires a 12 amp hour battery. Now, if it's a gel cell, it can be charged at a maximum of 6 amps, as we said earlier, or 72 watts. So the maximum panel size, again, we can have is 72 watts. The solar input requirements. My 3 hour charge rule says I'm going to need a minimum of about 50 watts. And so for size and weight, I would probably choose a thin frame. Now you can buy solar panels in different frame types and so on, and they have different weights. So I would choose a thin frame 60 watt folding panel which supplies around 5 amps. And that'll give me some extra safety margin, again, like we discussed, for cloudy days and what have you. Okay, next is the controller matching. So we've matched the battery so far. That was in the last video. We've just now matched the solar panels, and now we have to look at a controller that will match, that will live with the power requirements of the panels and the batteries and the output. Summary of output matching. So the battery, 12 amp hours, we determined that earlier. The output, 4 amps is what we decided we needed. We're going to operate 2 devices simultaneously. The solar panel, we need 5 amps input to the controller, and that would be 60 watts. The controller, 10 amps. 10 amps is okay. 20 or 30 would be better, just because it'll handle the load, you won't overheat it, and so forth. So if we stay within this range, the configure is going to work very well for a long time, and my experience is it has. Okay, next video is putting it together. We're going to make it. We're going to build it.